Hello my viewers, welcome back. This is your teacher Pascal or Mr. Distinctions. If you're new to the channel, kindly subscribe so that you keep on following me. And also on this channel, we do not have only chemistry, but we have all the composite subjects. We learn mathematics, biology, physics, English, and also chemistry, as you can see. Check for my previous videos so that you can watch, because I've explained some topics, some important topics which you need to know as a pupil who wants to pass his or her final examination. Don't forget to put a like and a comment if you find my videos to be helpful. Also, don't forget to share. Okay, so in this video, I want you to understand this topic. This topic, which is called organic chemistry, is an important topic, and most of the pupils do not understand this topic. So I will explain so that you understand it very well. Therefore, I encourage you or urge you to watch this video up to the end so that you understand this topic. And at the end of it all, you pass your final examination, because I know your wish is to pass your final examination. And I know that you want to have good results, because I've gotten good results. I can also make you to have good results. That's why I urge you to keep on following me. Okay, so we are talking about organic chemistry. And the first question is, what is organic chemistry? What is organic chemistry? Okay, so if you talk of, when you talk of organic chemistry, we are just talking about the start of what? Of carbon. So when you talk of organic chemistry, just the start of what? Carbon and its what? Its compounds. So when you talk of organic chemistry, we are just talking about the start of carbon and its compound. I know that we know that carbon looks like this. Okay, let me just clear this part. We know that carbon looks like this. So now, the study of this same carbon and its compound, when carbon reacts with a certain element, the compound which is going to be formed is the one which we are calling the compound of carbons. So that compound which will be formed as a result of the reaction of that element with carbon is the one we are calling organic compounds. So the study of this carbon and its compound, the compounds which are formed as a result of the reaction of carbon and other compounds, those compounds which will be formed are the ones which are referred to as organic compounds. So when we talk of organic chemistry, we are just talking about the study of what? Carbon and the compounds which will be formed after carbon is reacted with other elements. Okay, I hope you are getting the points. So that is organic chemistry. If you read in other books, organic chemistry is defined as the study of carbon and the compounds of what? Of carbon, except carbonates, carbon monoxide, carbon dioxide, and the carbon disulfide. So if you read in other books, you will find that is a definition which they normally give. But in simpler terms, we are just saying that it is just a study of what? Carbon. This carbon, which is right over here, and its compound. After this carbon is reacted with another element, that compound which is going to be formed, that is what we are referring to when I say its compound. Okay. So here what you have to understand is that the compounds of carbon are many, because carbon can react with main elements. Hence, the compounds which are formed are main. Now, these compounds have been put in families. Let's take, for example, we've got these as organic compounds. This is a good example. I want you to understand. So these are organic what? Are organic compounds. All these you are seeing are organic compounds. So now these organic compounds have been put in groups or in what? In families. What is the reason? Among these organic compounds, some are resemble to others. Let's say, for example, if you can see clearly, you can see that we have got these O's. These we are going to get this as a family. So this is a single family. Also, this as a single family. Also, this as the single family. So as you can see, we've got three families: 1, 2, 3. But all these families, the members which are in these families are what? Organic compounds. I hope you are getting the point. So all these are organic compounds. But since there are some which are resemble to each other, we are going to group them, or we are going to put those in one group or in one family. Also, we have got these which are resemble to each other. We are going to put them in another family. So we've got two families. We've got this family and this family. And these, as you can see, are resemble to each other. We are going to put them in one family. So we've got three families. So in short, what I'm saying that organic compounds have been put into families. What is the main reason? Because some members of the families or some members of organic compounds resemble to each other. And for that reason, they have been put in what? In families. So here are some of the families we need to know. So here are some of the families we need to know. The families of what? Of organic compounds. So number 1, we've got the first family, which is called alkane family. Then number 2, we've got a family which is called alkene family. Then we've got a family which is called alkyl family. Then we've got a family which is called acid family or carboxylic acid family. Then the last family which we have is the family which is called esters. Okay, so these are what? Are families of organic what? Organic compounds. Remember, the members which are in these families all are organic compounds. But since these members in alkane family have got some similarities, that's why they have been put in one family. Also, these members in alkene family have got some similarities. That's why they have been put in what? In one family. Also, when talk of the members which are found in alkyl family have got some similarities. That's why they have been put in what? In one single family. Also, the families which are found in acids have got some similarities, which I will explain. That's why they have been put in what? In this family. Also, these members, the members which are found in esters, have got some similarities. That's why they have been put into what? Into one family, which is called ester family. I hope you are getting the point. So, what we are saying in short is that all these are organic compounds. But since some members resemble to each other, those members which are resemble to each other have been grouped and have been put in one group so that they can make a family. So there are some members which have made up a family which is called alkene family. Then there are some members which are resemble to each other, and those members have been put together and they make a family. They have created a family which is called alkene family. And there are some members which are resemble to each other and they have been put in one family. They have created a family which is called alcohol family. Also, the same applies to what? Acid family. And also, the same applies to what? Ester family. Ester family has got members which are resemble to each other. I'm going to explain further as we'll be proceeding with our study. Make sure you watch it up to the end because I want you to understand this topic so that you can be able to be answering all the questions. Okay, so in short, organic compounds have been put into families. And the family which I want us to talk about is number 1, alkene family. Number 2, alkene family. Number 3, alcohol family. Then the remaining one, we'll talk about them in the next video. So I want us to understand these families. I want us to look at some members which are found in alkene families, then some members which are found in alkene family, then we are going to talk about some members which are found in alcohol family. Okay, now before that, I want us to understand something. There are some terms which are used when you're talking about organic chemistry. There are some terms which are used, such as hydrocarbons. Hydrocarbons. So this is one of the terms which are used, which is used in when we are talking about organic chemistry. So hydrocarbon. What are hydrocarbons? So hydrocarbons, whenever you hear hydrocarbons, just know that we are just talking about compounds which have only 2 elements. And those elements are hydrogen and what? And carbon. So when you talk of hydrocarbon, we're just talking about compounds which have only 2 elements. And those elements are carbon and hydrogen. So these compounds which have got only 2 elements are the ones which we normally call hydrocarbons. Let me maybe give you an example so that you may understand very well. There is a compound which is called methane. I'm sure you have heard of it before. There is a compound which is called methane. Methane its chemical formula is CH4. I'm sure you have seen this compound before. Methane is an hydrocarbon compound. Is an hydrocarbon. What is the reason? Remember, we said that hydrocarbons are compounds which have got only 2 elements, and those elements are carbon and what? Hydrogen. We can also talk about I know that maybe you have heard of ethene. If you haven't heard of ethene before, don't worry, I'm going to explain. you are going to understand. And the reason why I'm writing this chemical formula, like the chemical formula for ethene is C2H4. The reason why I'm writing this, I'm going to explain, and you will know how to write these chemical formula. So when talk of ethene, ethene qualifies to be called a hydrocarbon. What is the reason? Because if you can look at this chemical formula, you can see that this chemical formula has got only two elements. It has got carbon and what? And hydrogen. So when we talk of hydrocarbons, we're just talking about what? Compounds which have got only two elements, and those elements are carbon and hydrogen. I hope you have gotten the point. Okay, let's talk about another example or another term which is used in organic chemistry. What is the next term which is used in organic chemistry? Okay, so the next term which is used in organic chemistry is homologous series. Homologous series. Okay, I want you to understand this. When we talk of homologous series, a homologous series is just a family of similar organic compounds. Remember, at first I say that organic compounds are compounds which contain carbon. The compounds of carbon are the ones which we normally call organic compounds. Any compound which has got carbon is called an organic compound, except those which I mentioned. Okay, so these organic compounds are many, and like I was explaining, since there are many, some of them are similar to each other, and they have been put in groups. And those groups, like I explained, are the ones which we normally call the families of what? Organic compounds. So when we talk of a homologous series, we're just talking about a family of similar organic compounds. So a family, in other words, homologous series is just another term of a family of similar organic compounds. So when we talk of a family, we can use this term homologous series. So a single family, instead of calling it as a family, you can call it as a homologous series. So a homologous series is just one and same as a family. So now a family of what? A family of organic compounds. A family of organic compounds is the one which is called a homologous what? Series. And each member in that family is called homology. Each member in that family is called what? Homology. Each member. And I said, remember, I said that we have got how many families? In fact, we've got many families, but in this video, we're going to talk about how many families? 3 families. And these families include alkanes, then alkenes, then we've got also what? Alcohols. So these are homologous what? Series. This is a homologous series, this is a homologous series, and this is a homologous series. That's why I said that a homologous series is just the other term of what? Of a family, because this is a family which has got members inside it's inside it. Then this one is also a family which has got members inside it. Then this one also is a family. So the other term which we can use, the chemical term which you can use, instead of saying a family, you can say this is a homologous what? Series. Also, this is a homologous series. So the members which are which are found in this family, each member, that's what we are calling a homology. A member which is found in this family or in this family or in this family is the one which we are calling a homology. I'm sure you are getting the point. Okay, so that is that. All right, so now what you need to know is that we've got, of course, many terms when talk of organic chemistry. There are many terms which you need to know for you to understand very well this topic. And so far we've talked about two terms. Number one, we've talked about hydrocarbons, of which you can try to define this term, hydrocarbons. Number two, we've talked about what? Homologous series. And we've said that hydrocarbons are compounds which have got only two elements, carbon and hydrogen. But when we talk of a homologous series, we're just talking about a family which has got similar organic what? Organic compounds. Okay, let's talk about another term. Let's talk about what? Another term. Actually, we've already talked about it. The other term which we can talk about is organic compounds, and that's why I've said we've already talked about it. In talk of organic compounds, when talk of organic compounds, we're just talking about what? The compounds which contain what? Carbon. So organic compounds are compounds which contain what? Contain carbon. So any compound which contains carbon is called an organic compound, though we have some exemptions. For example, the carbonates, carbon monoxide, carbon dioxide, and the carbon what? Disulfide. So those are the exemptions. There may be others, but those are some of the exemptions. So now, any compound which contains carbon, except those, is the one which we are calling an organic what? An organic compound. I'm sure you're getting the point. Okay, so that is another term. Let's talk about the last term. Then we'll start looking at the families. Okay, the last term which I would like to talk about is functional group. I want you to understand this functional what? Group. Okay, so when you talk of a functional group is just a group, or a functional group is a group. Yes, it's just a group which determines the chemical properties of what? Of organic compounds. A functional group is a group which determines the what? The chemical properties of organic compounds. So organic compounds have got different what? Chemical properties. Now these chemical properties, what determines the chemical properties of these organic compounds are what? Functional groups. So each family has got its own functional group. Okay, maybe let me just write the definition in case you are writing. So in talk of a functional group is a group which determines the what? The chemical the chemical properties of organic what? Compounds. Okay, this is organic compounds. So when talk of a functional group, we're talking about a group which determines what? The chemical properties of organic compounds. And when talk of chemical properties, we are talking about how these organic compounds react with other elements. Those are the chemical properties. When we talk of the chemical properties, we are just talking about the reactions they undergo. So each and every family of organic compounds have got a functional group which make them to react differently from other what? From other families. I'm sure you're getting the point. Each family of organic compounds react differently from other what? Other families. What is the reason? Because each family has got its own functional group. And for that reason, each family reacts differently from the other ones, the other families. Okay, so let's look at some of the functional group of some families or some homologous what? Series. So let's say, for example, when we talk of alkanes, alkanes have a functional group which looks like this. Okay, have a functional group which looks like this. Okay, let me just do this. Okay, this is the functional group of what? Of alkanes. So this functional group is a single carbon to carbon covalent what? Covalent bond. As you can see, we've got this single bond, single bond, single bond. So this is a functional group of what? Of alkanes. Whenever you just see carbons bonded to single bonds, bonded using single bonds, just know that member of organic compound comes from where? From alkanes. Because alkanes are the ones which have got this functional group. Okay, let's look at so what I've said is that alkanes, okay, just do this. Alkanes have got this functional group. Let's look at alkenes. So alkenes have got this functional group. I've got what? Double bonds between carbon atoms. So these functional groups are the ones which determine the chemical reactions which these members in this family will be undertaking. So as you can see, we've got different functional groups. We've got different what? Functional groups. And for that reason, the members which are found in alkanes family will be reacting differently from the members which are found in what? In alkanes family. What is the reason? The reason is simple. Because they have got what? Different functional groups. And like I said earlier on, functional groups are the ones which determine the chemical reactions or the chemical properties of the members of the families. And when I say the chemical properties, I'm talking about how these families these members in each family will be reacting. Okay, I hope you are getting the point. What about alcohols? So when we talk of alcohols have got this functional group OH, which is called hydroxyl group. Hydroxyl group. So this functional group, which all members which are found in alcohols have, makes the members of this family to react differently from the members which are found in where in this family. I hope you are getting the point. Okay, so when we talk of the functional group of acids, when we talk of the functional group of acids, okay, let me do this. So here we've got double bonds, then here we've got hydroxyl. Okay, now, so when we talk of the functional group of acids, this is a family which is called alkanoics or carboxylic acids. Carboxylic acids or alkanoids. Let me just use this term so that it get used. So alkanoics. So these are acids actually. Okay, so the functional group of which the members of this group have looks like this: COOH. Don't worry, we're going to understand the use of these functional groups. Of course, I know that you know that I've explained that the use of these functional groups. These functional groups are the ones which are responsible, which determine how the members of each family will be reacting, or are the ones which determine the chemical properties which the members of this family will have, the members of this family will have, the members of this family will have, also the members of this family will have. Now we are going to understand further as we'll be proceeding. Okay, let's talk about the last organic family, which is the ester family. So what is its functional group? So its functional group looks like this: COO and the open bond. So this is how it looks. When talk of the functional group for alkanoics or acids, this functional group, which is right over here, this functional group is called carboxyl group. Carboxyl group. Let me just write it. Carboxyl group. Okay. Carboxyl group. So this is how we call this functional group. Then when we talk of this one, the functional group for this family, which is the ester family, this functional group we normally call it ester functional group. Ester functional group. Ester functional group. Okay. Ester functional group. I hope you have gotten the point. All right. So now, remember, I've said that we are going to talk about 3 families of these same organic compounds. We are going to talk about alkanes. Also, we are going to talk about alkenes and alcohols. So what you need to understand and know is that the members of each group has got different what? Different names. So we're going to learn how do we name the members of what? Of each the members of the families of each family. I mean the members of the members of each family. So we are going to learn how to name, or how do we give the names to the members of different what? Families of organic compounds. Okay, so whenever you are naming any member of any organic compound, we normally use what is called nomenclature of organic compounds. We normally use what is called nomenclature. So when we talk of nomenclature, in this case we're talking about nomenclature of what? Organic compounds. So when we talk of nomenclature, before we even talk about nomenclature of organic compounds, when we talk of nomenclature is just a standardized way of naming organic compounds. Maybe you can be asked, what is the nomenclature of what? Of organic compounds. It is just a standardized way of what? Of naming organic compound. So the standardized way of naming organic compounds the one which are calling nomenclature of what? Of organic compounds. So what you need to understand here is that whenever you are writing any name of any member from any family, the name of organic compounds have got two things. Number one, they have got what we normally call a prefix, which is the first party of the name. First party of the name. Okay. Then number two, we've got what we normally call suffix. So when we talk of suffix, we are talking about the last part of the name. I want you to understand, I want you to follow me carefully so that you understand how do we name the members of organic compounds. So here are the points. Number one, each and every organic compound has got a prefix, and then a suffix. A prefix, as I said, is the first part of what? Of the name. Then when you talk of a suffix, it's just the last part of what? Of the name. So now, what you need to understand is that when you talk of the prefix shows the number of what? The number of carbon atoms in an organic compound. So the first part of the name shows the number of what? Of carbons which that particular organic compound or that particular member has. Let's say, for example, whenever you see any organic compound or any member has got a prefix which is meth, then just know that that organic compound has got how many number of carbon atoms? 1. Then whenever you see okay, let me just do this. So we're saying meth 1. Then whenever I see any organic compound or any member from any family has got the prefix which is eth, just know that that member has got how many number of carbon atoms? 2. But whenever you see any member from any family has got a prefix which is prop, just know that that member has got how many number of carbon atoms? 3. Then whenever you see any member has got a prefix which is but, then that prefix that member has got how many number of carbon atoms? 4. Then whenever you see any member has got a prefix which is pent, just know that that member has got how many number of carbon atoms? 5. I hope you are getting the point. Then whenever you see any member has got the prefix has got a prefix hex, then just know that that member has got how many number of carbon atoms? 6. Then whenever you see any member has got a prefix which is called hept, then just know that that member has got how many number of carbon atoms? 7. Then whenever you see any member has got a prefix, the first part of the name is oct, just know that that member has got how many number of carbon atoms? Has got 8. Okay. Then whenever you see any member has got a prefix which is non, just know that that member has got how many number of carbon atoms? 9. Then whenever you see any member, whenever you see any member has got a prefix which is dec, then just know that that member has got how many number of carbon atoms? 10. So meth means, when talk of meth means 1 carbon atom, eth means 2 carbon atoms, prop means 3 carbon atoms, but means 4 carbon atoms, pent means 5 carbon atoms, hex means 6 carbon atoms, hept means 7 carbon atoms. Then when talk of oct means 8 carbon atoms, then non means 9 carbon atoms, then lastly dec means 10 carbon atoms. I'm sure you are getting the point, and this is just a simple thing. You are going to understand further. Do not stop watching this video. Hold this video up to its end. You are going to understand the concept. Don't worry. Okay, so now how do we remember? Because maybe you can forget how to list these prefixes. You can forget. So here is a word which we can be using to remember these prefixes. So the word goes like this: mep, which is meth, then eth, then prop, mep, then BP. I'm sure you know BP, blood pressure. So BP, this is but, then this is what? This is pent. Mep, BP, HH. Mep, BP, HH. This is actually hex. Then this is what? This is hept. Then BPHH O on D. This is oct. Then this is what? This is non. And lastly, this is what? Dec. So we have MEP, BP, HH on D. Okay, I'm sure you can be able. I'm sure you can be able to remember this. Then the other thing, which maybe to master this may be a challenge to you. You can use a sentence. I'll construct a sentence in order for you to remember how you can be writing the list, because this M should not be placed here. Reason why? Because if you place this M, which is meth, if you place meth right over here, you mean that n member which has got meth to its front has got how many number of carbon atoms? 3, because this prop means 3 number of what? Carbon atoms. So this meth always has to be to the front. Then this F has to follow meth. Then and so on and so forth. So the other, I'll construct a sentence. You can write. It is very important. It is very important to write. You know, you have to be revising. So if you can't remember with this, you can use, let me just rub the board. If you cannot remember using that strategy, you can use, here we've got okay, so you can use most, then elephant, most elephant, most elephant pass by public, most elephant pass by public houses have orange, not dark. Then to complete the sentence so that it can make sense, you can write color. Okay, so most elephants pass by public houses have orange, not dark. Then to complete the sentence, color, so that it can make sense. So most elephant pass by public houses have orange, not dark color. I'm sure you can see that it is very nice. So that's how you can be remembering these prefixes. Okay, what about the suffixes? So when we talk of suffix, we are talking about the last part of the name. The last part of what? Of the name. All organic compounds have got the same prefixes, and those prefixes are the ones we have just from talking about: meth, eth, prop, but, pent, and so on and so forth. Those are the prefixes which we normally use whenever we want to write any member of an organic compound. Now, how do we know that this member, for me to write this member, you have to use meth? Or how do you know that for me to write this member, I have to use the prefix pent or eth or n prefix? Right, we are going to learn. Don't worry, just keep on following me. Okay, so now let's talk about the suffix. When you talk of suffix, is just part of what? Of the name. So now each and every organic what? Family has got its own what? Suffix. So each and every what? Each and every family has got its own suffix. Let's say, for example, the suffix for alkanes is A-N-E. So whenever you will just see A-N-E, just know that that compound, that member comes from where? From this family. So if you get a prefix, a certain prefix, let's say for example, we get meth, then we get the suffix. This is methane. So now this name is showing us two things. The first thing, this name is showing us how many number of carbon atoms are in this compound, which is methane, and from which family is this member belongs. So the first part, this part is showing us how many number of carbon atoms are in this organic member, and meth represents or means 1. So in this organic member, we've got only one carbon atom. When we write the chemical formula, methane has got only one carbon atom. Don't worry, I'm going to show you, and I'm going to show you how to write the chemical formula. Don't worry, keep on following me. Then this last part, which is the suffix, is showing us the family in which this member belongs. So whenever you just see A-N-E, whenever you just see the suffix which is ending like this, A-N-E, just know that that member, which is right over here, methane, belongs to where? Belongs to the family which is called alkanes. I hope you're getting the points. Okay. What about alkenes? What about alkenes? When you talk of alkenes, the members in this of this family have got the suffix which is E-N-E. Whenever you see E-N-E, any compound, organic compound is ending with E-N-E, just know that that compound belongs to alkenes. Let's say, for example, when talk of let's take earth. Remember meth, earth. Then we write E-N-E. What we are going to have is ethene. So here, what we are seeing is that this ethene is showing us two things. Number one, this ethene, the prefix is showing us how many number of carbon atoms are in this organic compound. So this prefix is showing us how many number of carbon atoms are in this compound. So if actually it means two number of carbon atoms. Then the last part, which is the suffix, is showing us where this compound, in which family does this compound do what? Belong. So ethene belongs to which family? Alkenes. What is the reason? Because this is the suffix of what? Of alkenes. I hope you are getting the point. Okay, let's talk about alcohols. So whenever you see alcohols, so in talk of alcohols, whenever you see the suffix ano, just know that that member belongs to which family? Alcohols. Let me give you an example. Let's take, for instance, the prefix we have is if, which is showing us that this compound has got how many number of carbon atoms? 2. Then we've got ano, which is showing us that this compound which I've made belongs to where? To alcohols. Belongs to the family which is called alcohols. So if you can read, this is ethanol, and ethanol is very common. So ethanol belongs to which family? Alcohols. I'm sure you're getting the point. That's why ethanol is used to make what? To make beer. Is added when beer is being produced, because ethanol belongs to which family? Alcohols. I hope you are getting the point. Okay, let's talk about the suffix of acids. So in talk of carboxylic acids, the suffix of carboxylic acids, okay, sorry. So in talk of the suffix of carboxylic acid is actually anoic. Okay, anoic. So whenever you hear, let's say for example, we get eth, then we add anoic. So we have got ethanoic acid, and I'm sure you have heard of ethanoic what? Acid. So this is how actually the name comes up. Okay. When talk of esters, the suffix for esters, is actually what? Anoate. Ethanoate, also propanoate. We are talking about what? We are talking about esters. Alright, so this is how we normally write the names. So the name of an organic compound has got 2 parts. That is the summary. The name of an organic compound has got how many parts? 2 parts. Number 1, the prefix. And what does the prefix show? The number of what? Of carbon atoms. Let's say for example, if you got meth as the prefix, then we'll know that this compound which we are going to form has got only 1 carbon atom. If you got eth, then this compound has got what? 2 carbon atoms. If you got prop, then this compound has got how many carbon atoms? 3. If you got but, then this organic compound has got how many number of carbon atoms? 3. So now the last part, which is the suffix, shows in which family does that organic compound belong. Let's say for example, here we've got prop, then we've got ane, so this is propane, and ane, whenever you just see ane, just know that what we're talking about are alkenes. In the family, this member belongs to which family? To alkane family, because alkanes are the ones which have got this suffix. Then whenever you just hear, let's say for example we've got meth, then we've got ene, methane, just know that this member belongs to alkenes group, alkene family, because alkenes are the ones, the members in alkene family are the ones which have got this what? This suffix. And whenever you, let's say for example we've got but, then we have an ano, butano. So this butano, you can see that in the first place, this compound has got how many number of carbon atoms? But means 4. And the other part shows us what? Shows us where this compound now belongs. So if you can see, we've got ano, which means that this compound belongs to which family? Alcohols. So that's what we can say. Right. I hope you are getting the points and you have understood. Having said that, let us now look and start looking at some families. We are going to look at some families. We are going to look at 3 families. Number 1, we are going to look at alkanes. Number 2, we are going to look at what? We're going to look at alkenes. Then we are going number 3, we are going to look at alcohols. Okay, so let's talk about alkanes as a family. This is a family. So when you talk of alkanes are hydrocarbons. I want you to understand very well. Alkanes are hydrocarbons, which means that the members of this family have got only 2 elements, and those elements are hydrogen and what? And carbon. So these are hydrocarbons. Maybe you can be asked to say, among the families of organic compounds, which family have got members which are hydrocarbons? Number 1, just remember alkanes. Of course, even alkenes, I'm going to explain. Even alkenes are hydrocarbons, but let's first understand this. Alkanes are hydrocarbons. All the members which are found in this family have got only 2 elements. I've got number 1 carbon, number 2 hydrogen. Okay, so alkanes are called saturated what? Hydrocarbons. These are saturated hydrocarbons. These are saturated what? Saturated hydrocarbons. Saturated hydrocarbons. These are saturated hydrocarbons. What is the meaning of this word? Because it may not be familiar. Saturated. These are saturated hydrocarbons. When we're talking about something which is saturated, we're talking about something which is not requiring anything. That thing is full. It is not requiring anything. Now, how do we relate that with what we are learning? Okay, don't worry. I'm going to show you. Don't forget to subscribe. If you haven't done that, don't forget. Also, don't forget to put a like and a comment if this video is helping you. Okay, so when talk of alkanes are saturated what? Hydrocarbons. I'm going to explain in detail. Just keep on following me. Okay, so having said that, let me explain this point. When talk of alkanes, each and every member, I mean each and every family of organic compounds, alkanes, alkenes, alcohols, also carboxylic acids and esters, have got general molecular formulae. Each family has got its own general molecular formula. So what I mean is that each family has got its own formula, which we normally use to write its members. Okay, let us understand. For example, when talk of alkanes, alkanes have got this family has got its general molecular formula, which looks like this: CN plus E plus 2, CnH2n plus E plus 2. This is the general molecular formula which we normally use when we want to write the chemical formula of any member from this family. Okay, so now maybe you can be wondering why this N, this N. So this N which is right over here, this N represents number of what? Of carbon atom. But what does it mean? Let me explain. So let's say, for example, we have been taught to write the chemical formula of methane. Write the chemical formula of methane. Okay, so when we talk of methane, of course we know that this name methane has got how many things? Has got two things. Number one, this name has got a prefix which is right over here, then a suffix which is right over here. So this prefix tells us how many carbon atoms are in this compound. So in this case, here we've got methane. We've got meth, and meth means one carbon atom. Then not only that, the suffix is telling us where this organic compound, which is methane, belongs. And A, N, E, whenever you see this suffix, any organic compound which has got this suffix, that organic compound belongs to where? To alkanes family. So now we want to write the chemical formula of methane. How do we write? The first thing, you need to consider the prefix. You know the number of carbon atoms you have. So here we've got only one, because meth means what? Meth means one. Then the second thing, you need now to write the chemical formula of that given member. How are you going to know that the chemical formula I'm going to use here is the one which the members of alkenes have, or the members of alkenes have, or the members of alcohols have? Right. The answer is very simple. What is going to tell you the chemical formula is the suffix. The suffix will tell you the family from which this member is taken. So in this case, we have got ANE right over here. So this is showing us that this member, which is methane, was taken from which family? Alkanes. So we are going to write the general formula for what? Alkanes. And the general formula for alkanes is CnH2n plus what? Plus 2. I hope you are getting me. Okay. So now let me just clear this part. Okay, we are writing the chemical formula for what? For methane. So the general molecular formula for alkanes is CnH2n plus 2. So now remember I said that N represents the number of what? Carbon atoms. And the number of carbon atoms which are in this compound, according to the name, according to the prefix is showing us that here we've got only what? One carbon atom, because meth means one. So we are going to replace N with what? With 1. So whenever we have N, we are going to put 1. So here is how it will look. 1 plus 2. Okay, so here we've got 1, and 1 we do not write according to the principles of mathematics. Then we've got then this 2 times this 1, the answer is what? The answer is 2. Then this 2 plus this 1, this 2, the answer is what? The answer is 4. And this is how we write what? Methane. I hope you have seen this chemical formula before, but you didn't just know, don't know how to write it. So this is how we write. Okay, let us look at another example. I want you to understand very well. So let's say, for example, we've been given F, and since we are talking about alkanes, what will be our suffix? Our suffix will be ANE. which will give us ethane. So now, how do we write the chemical formula of ethane? Wow. What we're going to consider is first the what? The prefix. Because we already know that this member belongs to which group or to which family? Alkanes, because of this ANE. So we even know the general formula which we are going to use. So this Earth means what? 2 carbon atoms. So we are going to write the chemical formula of what? For alkanes, because of this ANE. This ANE is saying that ethane belongs to which family? To alkanes family. So the general formula for alkanes family is plus 2. So here is how it will look. See, whenever we have N, we are going to replace it with 2. Then H. Then here we've got N. We are going to replace it with what? With 2 plus 2. Okay, so when we clear up, we are going to have this 2 times 2. The answer is 4. 4 plus 2. The answer is what? 6. And this is how our chemical formula will do what? Will look. This is the chemical formula for what? For ethene. Okay, let's look at another example. Maybe you can pause the video, then you try, so that you can see if you are able to write the chemical formula. So let's try. We've been given pentane. Okay, we've been given to write the chemical formula for what? For pentane. So the chemical formula for pentane, the first thing, maybe you can pause the video, then you'll try. Okay, so the first thing you need to consider is to know the number of what? Carbon atoms. Pent means what? 5. And if pent means 5, it means here we've got 5 carbon atoms. So where there is N, we are going to replace it with what? With 5. Then we are going to consider the suffix, because it is the one which is showing us which general formula. Because don't forget, I've said that each and every family has got its own general molecular formula. I'm going to show you as we'll be proceeding. Already I've shown you the general molecular formula for alkenes. There is also a general molecular formula for what? For alkenes, also for alcohols, also for acids, and for esters. So what I'm writing is the general molecular formula for what? For alkenes only. That general molecular formula, we cannot use it to write the members which are found in what? In alkenes or alcohols. No, it is only used to write the members which are found in what? In alkenes. That's so. Okay, so here, knowing that we've got ANE and this is alkanes, because are the ones which have got this suffix. So we're going to write the general molecular formula for alkanes, and the general molecular formula is plus 2. Okay, so where there is N, we are going to put 5, because we've got pent, which means 5. So we are going to have 5. Okay, let me just do this. We are going to have, we've got this general molecular formula. Okay, so what we are going to have is this 5 right over here, then H, then 5 plus 2, and this is how it will look. 5 means carbon, then this 2 times this 5, the answer is what? 10. 10 plus 2, the answer is what? 12. So this is how pentane looks. I'm sure now you have understood how to write the chemical formulae of these members, the members which are found in alkenes. Okay, so now having understood this, let us see how we can write the structural formula, because this is the chemical formula. Now, how do we write the structural formula? How do we write the structural formula of different members of alkanes? Okay, so here is how we write the structural formula of different members of what? Of alkanes. Let's say, for example, we've been given to write the structural formula for ethane. Okay, the first thing you need to do, you need to write the chemical formula, because the chemical formula is the one which determines how the structural formula will look. So this is ethane. So how do we write ethane? This is 2. Don't forget, this is alkanes. This represents alkanes. This represents 2. So we're going to write the general molecular formula for alkanes, and the general molecular formula for alkanes is this one. Then where there is N, we're going to put 2, because the prefix is telling us that this compound has got 2 carbon atoms. So here it is, plus 2. So 2 times 2, the answer is 4. 4 plus 2, the answer is 6. So when you clear up, you are going to have this. Okay, this is actually the chemical formula for what? For ethane. This is the chemical formula for what? For ethane. Okay, having done that, after you have written the chemical formula, let me just write it right over here. Okay. Alright, so having done that, now we can write the structural formula. So here, what you need to consider, just now need to consider the number of carbon atoms which you have. Here we've got how many number of carbon atoms? 2. So we're going to write carbon, another carbon. Now don't forget, when we are talking about functional groups, we said that alkanes have got single bonds between carbon atoms. I hope you can remember. So we are going to write a single bond. Don't make a mistake to write a double bond. No, because if you write a double bond, then this structural formula which we are writing right over here will represent what? Alkenes. Because alkenes are the ones which have got double bonds between carbon atoms. Okay, so we are going to write our 2 carbons, which are right over here, the one, also the other one. Okay, so remember, alkenes have got only single bond between carbon atoms. Okay, so how many hydrogens do we have? We've got 6 hydrogens. Don't forget, when talk of carbon, what's this? The electron configuration for carbon is this 2, 4, because carbon has got 6 as a proton number. So this means that if you can see, for an element to be stable, that element has to have 8 electrons in its outermost shell. So which means carbon requires more 4 electrons for it to be what? To be stable. Hence, carbon looks like this. It requires what? 4 electrons for it to be what? To be stable. I'm sure I'm getting the point. So it has to be bonded on 4 different parts, so that it can be stable, because it requires 4 electrons for it to have 8 electrons in its outermost shell. Okay, so that is what actually guide us. Whenever you're writing any structural formula, that is what must guide you. So here we've got this carbon which has got this bond, and this bond is also to this one, which means that we have remained with how many bonds? Three bonds. Okay, so we are going to count the number of the number of hydrogens we have. Here we've got 6 hydrogens. So we are going to put one hydrogen right over here, then another hydrogen right over here, then another one right over here. As you can see, we have bonded. This carbon has got now how many bonds? 4. If you can see, there is this bond which is right over here, then this bond, then this bond, then this bond. And since it requires 4 electrons, this carbon is okay or is stable. I'm sure I'm getting the point. Then we come to this one. This one also has got already this one bond. So this means that it is requiring now 3 bonds for it to be what? To be stable. So we are going to write 1. Remember here we've got 6 hydrogens, and we've written 1, 2, 3, 4, 5, 6. So if you can see clearly, you can see that this carbon also has reached its stability, because if you can see, it has got this one, this one, this one, and this one, and it has got 4 bonds, or it has acquired its full state. And this is how the structure for for a thing will look, because we've got 2 carbons, which is 1, 2. Then we've got 6 hydrogens, which is 1, 2, 3, 4, 5, 6. Alright, let us look at another example. Okay, maybe before that, I said that, or maybe I'll explain this point in this next example. Let's say, for example, I've been told to write the chemical formula for any member from the family we're talking about, alkane family. Any member. Okay, let's say, for example, we have been told to write the chemical formula for pentane. This pent means 5, so it has got 5 what? 5 carbons. Then this ENE, which is right over here, represents that, or is telling us that this pentane belongs to which family? Alkane family. Okay, so we're going to write the general molecular formula for alkanes. And the general molecular formula for alkanes is, don't forget, I hope you are writing somewhere, plus 2. So here, since we've got 5 carbon atoms, what we're going to have is 5, then 5 plus 2. And finally, what we're going to have is 5, then 2 times 5, the answer is 10. 10 plus 2, the answer is what? The answer is 12. So as you can see, this is how our chemical formula will look. Now let's talk about the structural formula. So the structural formula, as you can see, we've got how many carbons? 5 carbons. We've got 1, 2, 3. Okay, let me just do this. Okay, we've got how many carbons? We've got 5 carbons, as you can see right over here. So we've got 1, 2, 3, 4, 5. Don't forget, I said that carbon when we talk of alkanes have got only single bond between carbon what? Carbon atoms. Okay, so as you can see, we've got 5 carbon atoms which are right over here. Okay, so now we need to start bonding these hydrogens to these carbons. And remember, carbon has got 2, 4, which means that carbon requires what? Requires 4 more electrons for this to be what? To be stable. So we are going to put X right over here, X, then H, then H, also another H. Okay, maybe let me just do this. Okay, so this topic is very important, and I hope you have understood. The basic concepts. So here we've got C5H2. Five plus 2. So here we've got C5H, this one, then this one 10, 12. Okay, so if we were to write the structural formula now, we've got C. So we've got 5 carbons. Okay, then we're going to bond it. As I was saying, carbon requires 4 bonds. Let me just write it right over here so that it can look smart. Okay, so it requires 4 bonds. Okay, so as you can see, we've got this where we've been given 5 carbons, and if you can see, we've got this one, we've got this one, this one, and this one. We've got 5 carbons. So now, what about hydrogens? We've got 12 hydrogens. So if you can see clearly, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is how our structural formula will look. Remember, I said that alkanes are hydrocarbons. And these are saturated hydrocarbons. And I said that I will explain. Alkanes are said to be saturated hydrocarbons because they are full. As we can see, they have got all the bonds. All the 4 bonds are bonded. There is no place, a space where we can put another bond because it has reached its full. As you can see right over here. Also, this one has got these 4 bonds. Also, this one has got these 4 bonds. So these are saturated. When we talk of something which is saturated, we are just talking about something which is full. All right. So having explained this, we are going to end here. Then we'll continue in the next video. Don't forget to subscribe. Don't forget to share to your friends so that they may also understand and know this topic. I know you have understood. If you have any questions or any comments, you can put them in the comment box. Don't forget to like the video. Then also don't forget to put a comment. Subscribe. Also turn on the notification bell so that you know whenever you post a latest video. Otherwise, thank you very much for watching. Keep on following me.